Okay, hi guys, welcome to my channel. In today's video, we'll be exploring pandas, which is another module in Python, which allows you to express data in the format of tables and data frames. So we'll try to see how we can use this to express data in tabular formats, read in CSV files, read in Excel files, and do some analysis with all the functions which are available in Python. So let's get started. So first, let's import numpy as np, import pandas similarly with as pd. So let's say I have an array, which is, or a list. Let's try to understand first from the basics. So b is equal to list of 1, 2, 3. Now if I do pd dot data frame of b, what do I get? So you can see here that the default column has been created, which is 0 here. Okay, the default index which starts from 0 in Python. Now 0, 1 to these bold letters in the row level are the row indexes. This is the column index, and these are the values spread across different rows. Now, as soon as I make it a list of lists or a nested list, let's see what happens. Okay, now this is my C, and then I'll do pd.data frame of C. So you can see here the next nested list became the next row of the data frame. Similar to what happened in arrays as well. If I do np.array of C, I get the same thing. But the difference between the array and the color and data frame is that in arrays, you don't really get to see the row indexes and the column indexes, but here you get to see the column indexes and the row indexes. Whenever you see a line like this to indicate a tabular like structure, you can understand that this is a data frame. So if I do d is equal to, again, pd dot c, and if I do type of d, it becomes a data frame. And if I do d dot columns, what do I get? I get the default index, which starts from 0 and stops at 3 with a step size of 1. And if I d dot index 0 to 2, which means it will take 0 and 1 as row indexes. Now, can I create a data frame from a dictionary? Okay, let's try to see. So we saw that we could create data frames from list to data frame, arrays to data frame. What about dictionaries? Let's say I have a dictionary with name. Suppose we have something like this. Now, if I do pd dot data frame of d, this should be small d, right? What happened here? The keys of the dictionary got interpreted as the column names of the data frame, right? And of course, the key having this information will be column wise, because Gaurav and Istihaq belong to the column which is name. Dividend belongs to the company column. Salaries, these figures belong to the column which is salary. If I want to create a data frame, okay, of a numpy array, let's say, of a nested list, why don't we do one thing? Why don't we use functionality, say 0 to 4, which means 0, 1, 2, 3, 4 numbers. So you can see here, if your dimension does not match, it creates a problem. So if I do list of range of 4:9, okay, because here you have 4 numbers, here you have 5 numbers, so we have to make it 8. And now it has become a table with all the rows and columns. Now, if I want to take this further, I can still do it. Let me make this 8 to 12, right? And then here I can do something like columns is equal to A, B, C. And we have D as well, because we have 4 observations or 4 elements in every row, right? So you can see here the column names get changed as ABC. We can set the column name while creating the data frame as well. Okay, or we can create afterwards also. So let me just show you. Suppose I have this, and I suppose not initiate the column name. Okay, and let me call it as df. So this is my df. So df dot columns, if I set it to equal to the list of the column names. Mind you, number of elements inside the column names have to be same with respect to number of columns we have, of course. If I do that, now if I look at df, you can see that we have set the column names. In data frames, we can also set index names as well. So how many indexes, row indexes do we have here? We have 3 row indexes. So you can call it as a small a, small b, and small c. So now if I do df, you can see here that it will take ABC as the new row indexes. So in data frame, what we understood is that it understands rows and columns just like arrays, but at the same time, we can initiate names for those indexes and column names, which means that in arrays, we used to slice information based on the row or the column index number. But here, I'm sure we can slice it based on the names of the columns and the rows if it exists, right? So if I do df of a, because a exists in this data frame, the column name exists. See, I can slice out the information. But what kind of a structure is this? What is type of df of a? Let's try to see. It's a series. So whenever you extract one column from a data frame, it becomes a series, right? When you use one level of list, it becomes a series. Now, watch what happens when I include a double list. So what's the difference between this and this? The difference here is that here, if you look at this, it only signifies the row names or the row index names. Here, we also have the column index name. So this is basically a series and this is a data frame. Plus we have the line here. So it includes a data frame. Now, can I use a single list to extract multiple columns? So if I do of A and B, let's see if this works. It does not work, right? It is something, it's telling you something. It's saying key error, right? Which basically means that probably your series cannot store more than one column, because when you use for a single list to slice out information, it becomes a series. So probably I have to put double brackets here to extract multiple columns, which are more than one column, to extract information, right? So this becomes again a data frame. So a series can only contain one column. And I do it using one single level of list. If I want to extract a data from out of it, multiple columns, I have to put a double list. So now let's get back to the situation where we had, unequal number of elements in all these sublists. So we could not create the data frame as such, right? So if I make this as, say, now if I do something like this, now if I have this, right, you can see all the elements inside the lists, sublists are equal, and it has to be so that we can create, that number of columns. Makes sense. But if I do have another element here, we can see here that the entire list is considered as a single element, right? So the entire list here has become a element inside one particular column, because it did not adjust for the extra element which is there inside the third list. However, if you want to avoid this, I can simply do something like this. I can put a nan initiation. This nan means these are missing values. So what's the type of missing values? What's the type of this nan? It's a float. So guys, please don't get confused. It's not a string. It is designated as a float. Why? There are multiple reasons behind it. Typically, when we try to calculate the median, mean, or suppose we are trying to plot a distribution, sometimes what happens is that data frames may contain some missing values. Empty cells in Excel files and CSV files are read as missing values in Python. So in that scenario, when we read the data frame, right, we suppose you do a distribution plot or some kind of figures you are plotting. Even if it has nan values, it will ignore the nan values and plot it for you. And if the type of the nan value is float, then the entire column becomes a float, because the type of nan is string. Wherever it has missing values, the entire column will be presented as a string, right? The same way in arrays, right? We understood that it can only contain one type of element. So in data frames also, one column can contain only one type of element. So we can in fact check it right here. So if I do something like this, okay, and if I have a string here, let me make it as 5. Okay. Now if I do df, suppose this is my this is my, say, df1, and this is df1 again. And if I do df1 dot d types means the type of data which is present inside each of these columns. So these are the column names which you see here, 0, 1, 2, 3, 4, and this is the type of the the nature of the data which is present inside each of these columns. So you can see here, because of this one single string, each of these elements inside the array became a string. Once each of these elements became a string, the entire data frame became a string, because one column in data frame can contain only one type of data. Now, however, if I do with, let's try to check it with lists, because lists allow you to store multiple types of data, right? Let me remove the array part from here. Right? I can simply remove the array part. Now, if I do this, let's say df2.dtypes, you can see here only that particular column which contains string 2 is object, because in lists can have multiple types of data within the list. So this entire list is intact, right? So 0, 4, and 8 belong to the first column and it is intact with the integer type. Whereas for np.nan is a float type. So 5, np.nan, and 12 became float because np.nan is a float type. The entire column got converted to a float, right? So this is, you can see here, 5.0 and 12.0. So 2, 6, and I think 10 will have an object. Unlike in arrays, because of this presence in arrays, the entire, that entire list of elements became a string, because arrays can only store one type of element at a time. So many minute things can be observed only when you practice and you get your things done, because there's so many functionalities available in Python, right? So you can use both arrays or lists to construct data frames which suits your purpose. So these are some of the distinguishing factors which one needs to evaluate and understand while reading Python. And without guidance, it becomes a bit difficult. Now, if you want to find out missing values in a data frame, how do you do that? So if I do df dot, now df2 has a missing value, right? We understood that is null. If I do simply dot is null, it will give you all true and false values, the Boolean, right, result which we get. And you can see here, this is true, which means that there is a missing value in 4 index column, right? And if I do dot sum, it will give me the column wise number of missing values that it has. So 0 missing values in 0, 1, 2, 3, 4, and finally we have 1 missing value in the index 4 column, which is this nav. Mind you, there is one more thing I want to point out here. When we convert it from arrays to data frame, you can see here this is small nan, whereas this is capital NAN, right? What is the difference? This is a float. This has become a string. That is why it is causing issues, right? Because I told you, right? Now, if I do here, now let's check out missing values in df1. It won't be there because this nan value has been converted to a string because of that one string present in one of the lists, right? So everything got converted to a string. And once it's a string, it will not recognize it as missing values. It has to be in the same format of np.nan or float. Then only it will recognize it as a missing value. So you have to be very careful. So while reading Excel sheets, even there is a empty space there or something like that, it will not be recognized as missing value. Okay, guys, that is all for today. I hope this was interesting. We'll come up with more interesting functionalities with pandas, and slowly and steadily you'll get a flavor of enjoying how easy it is to evaluate data in using Python. Stay tuned. Please like, share, and subscribe if you have liked this video. so that we can reach out to more and more people. Thank you so much.